Today we are going to talk about link state routing. Link state routing, each router shares its neighborhood knowledge with every other node in the internetwork. The link state routing algorithm is also known as the Dijkstra algorithm, which is used to find the shortest path from the one node to every other node in the network. What are the features we are going to see about the state routing protocol? Link state packet, that is the smallest packet which contains the routing information. Link state database, a collection of information gathered from the link state packet, and then shortest path algorithm, which is used as the Dijkstra algorithm, a calculation performed on the database results in the shortest path. And then routing table, the list of all the paths which is noted between each node, and then interfaces. Everything will be there in the routing table. Link state routing. So already I explained the list of nodes and links should be there which is connected, and or knowledge about all the nodes are noted in the particular node based on few metrics. One is the type of the links, and then cost. Cost is also the metric which is used to identify the link state, which is the least cost, and condition of the links, either uplink or downlink. The node can be used using the Dijkstra algorithm to find the shortest path with the routing table. The concept of the link state routing here in this scenario, 5 nodes are connected together with different cost metrics. Here A to B, it is connected with cost metric of 5. From A to C, it is connected with 2. So similar kind, 5 nodes are connected here. In each node, all the systems which is identifying, one will be the root node, other nodes are connected node. We need to identify the shortest path. So that way only we are going to connect the link state. So link state knowledge we are going to gain from, so in the initially A state link has the knowledge of 5 as the distance metric from A to B. Then from A to C, the distance metric is 2. Then A to D, the distance metric is 3. So these are the knowledge which is captured at the node A. And then node B, the links are connected with, from A to B it is 5, from B to C it is 4, and then B to E it is 3. So each and every node will have the link state knowledge, which is the meaning that particular node, how it is linked to next node, in what kind of metric it is measured. That is also we are going to talk about in the link state knowledge. Now we need to do the building routing table. So for that we are going to create the states of the links by each node, which is called as a link state packets. Already we have identified what is a link state packet, which has the routing information, and then distribution of the link state packets to every other node, which is identified through the flooding. Flooding is giving all the information to all the nodes, that is which is the shortest path, and then how much cost is needed to link from one node to another node. Everything will be identified through the flooding only. Then formation of shortest path tree for each node. This formation of shortest path tree from each node is we are going to identify with the Dijkstra algorithm. Then calculating the routing table based on the shortest path tree which is provided through the Dijkstra algorithm. So this is the way we are going to build the routing table. So this is the Dijkstra algorithm. First we are going to set the root node. So set the root node to the local node and move it to the tentative list. First we are identifying the tentative list is empty, means we are going to stop. If the tentative list is not empty, then we are going to move, which is the first permanent list will be moved with the root node. Then identifying the shortest path and moving that node to the permanent list. And each time we are going to identify the neighbor node till the last move node is identified as a tentative list. If already there, we are leaving, otherwise we are moving each and every node to the tentative list, and then we are arranging the cumulative cost and replacing with a new one. So this process should be done till the tentative list is empty. How the process happens? This is the example of formation of shortest path tree. So the topology, entire topology is given at the top. The root node is A. From A to E, we need to identify the path. So from A, root node A, the first path is B. So which comprises the metric, cost metric of 5. So A to move A to the permanent list initially, and then from A we need to add the next neighbor node B, C and D. Then we are identifying which is the shortest one. C is the shortest one. So we are moving C to the permanent list and add E to the tentative list. Then move D to the permanent list. Then we are moving B also to the permanent list. Then move E to the permanent list, and then tentative list is now empty. So one by one the informations are gathered together which identifies the shortest path. Now we are going to, after identifying the shortest path from the root node, we are going to provide the routing table for node A. This is, we are considering from node A, that is the root node, to which is the shortest path for the next router, that we are going to, that is next hop we are going to identify. From node A the cost is 0, from B which identified as a metric as 5, and then from C to D 3 and then E 6. But the next hop is the shortest path is 2 and 6. So we are moving via C. So next router is identified as C as the shortest path. This way only we can easily identify the link state routing information. So with that I am completing the introduction related to routing table using the link state protocol. So thank you.